Hello everyone. My name is Achala. So I'm from Meetrix. I think most of you are new to us. I haven't seen most of you before. Very nice to have you with us for this conference. So I'll just start my presentation so we can get going. This session is on open source video conferencing for enterprises and startups. So let me introduce myself briefly. I'm Achala. I'm a WebRTC automation consultant at Meetrix. So I help businesses get on board with video conferencing using open source software. And then my colleagues, Jay, who is the principal engineer, and Dilushan, who's a tech lead and a DevOps engineer, will also take the presentation forward. And finally, Jamini, our project manager, will wrap things up. So this is the brief overview of the content. So we will talk about why someone would self-host video conferencing and how they can save money and also enjoy the power of open source. Some brief overview of use cases and advantages of video conferencing. And we introduce Jitsi and how that can be auto-scaled, and then also some challenges Jitsi faces, some aspects of security, working with firewalls. Then we talk about other open source software which is available, and then a little bit about us so that you can understand what sort of services we offer. So why self-host? That's a big question. People would think when there are so many commercial options like Zoom or Google Meet or Microsoft Teams, why would I want to self-host? So basically, after COVID-19, most people work remotely, even sales staff or HR teams or lawyers from healthcare officers. So many people use video conferencing, and it has seen that there's a huge productivity increase when people working remotely would use video conferencing. That's about 50% more than just audio or traditional chat applications. Also, this is going to be a big market this year. It's going to reach $6 billion globally. So again, why self-host? Why would someone need video conferencing? It's because relationships are built on seeing and understanding one another. So it's very important that we all see someone or something before we get to start a relationship, to purchase it. And benchmark for this is video conferencing at the moment. There will be more exciting technologies taking over, real-time communications. So while we wait for the new novel technologies, video conferencing is also getting advanced leaps and bounds. So when you want to self-host, there are a few key questions that one should ask yourself. One is it going to be robust? Is it going to be secure? Is it going to scale enough? Is it open source or IP protected? Is there support? Is there maintenance? Would it be user friendly? And how can we integrate it with our existing applications? And then there are a lot more questions. But finally, it also boils down to cost. So again, is it going to be robust? Is it going to scale? Is it secure? So these are a few of the major things to consider if you or your customers are going to start self-hosted video conferencing for their technologically driven business processes. So again, if you want self-hosted web conferencing, you would want something which is secure, customizable, and also it should integrate well within your business applications, which might be B2B, B2C, or customer to business or customer to customer. So B2B is business to business, B2C is business to customer, and then like C2C is something like a novel social platform like Omegle, where people would just start talking with random other people. So then also you have to think about other compliance requirements. Is it like HIPAA compliant or GDPR compliant? What sort of other regulations your own company or external parties, your stakeholders would want you to adhere to? And then of course you also would enjoy saving money by self-hosting. So typically, this is the cost range for commercial platforms. It's about USD 12 to 15 per host or organizer or a moderator, and usually these commercial systems allow 100 to 150 users in a meeting. Google Meet is of course a little cheaper because it is sometimes rolled out with Google Apps, but other major brands like Microsoft Teams, Zoom, WebEx, and GoToMeeting have this sort of pricing. But there are other options also, which might be a little cheaper if you are very large. Saving big with especially Jitsi. So this is what some of our customers report. They say that the cost is about $5 or less, and you get unlimited hosts, unlimited moderators, which is a huge saving. And then you can, of course, comfortably host about 50 users in one conference with about 20 on video or up to even 75 with one or two people on video. So that's traditionally a 60% cost saving compared to commercial video applications. But you can even save more if you have the right infrastructure partners and other application protocols in place. So again, people would use video conferencing for a diverse range of applications, from entertainment to healthcare to social apps, and that number of use cases are ever increasing because people are integrating video conferencing even to things like smart helmets or glasses or wearables. So these exciting new areas WebRTC is stepping into, and of course team capacity building and also other traditional applications. Meetrix has been working in WebRTC from 2014, and we've been working with Jitsi since 2017. So that's about it from me. So Jay will take over, our principal engineer. Jay, over to you.
Hello everyone. Actually, will you be able to keep the slides there?
Oh yeah, yeah, sure. Sorry about that. Yeah. Okay.
Yes. Um, so hi everyone, my name is Jay. So this will be a quick introduction to WebRTC for everyone. It won't be very technical, but I'll just briefly go through the technologies. So WebRTC is a real, I would say that it's the real-time communication technology for the web. It's an open standard which allows direct media communication between browsers. It supports real-time audio, video, and data. The initial draft was published in 2011 by two Google engineers, and the stable version was released in 2018. So we can look at before WebRTC came into the picture, there were multiple technologies that have been used in RTC industry. Uh, for example, H323, SIP, and Flash. Um, WebRTC inherits some of the existing stack from these technologies, and the main difference is the WebRTC brought most of these capabilities into the browsers. So when you introduce something to the browsers, a lot of developers start using them, and now WebRTC libraries and technologies have been ported from browsers to other technologies like native SDKs, for example, in Java, C, and native binding for uh, mobile frameworks, native and so on. Um, when it comes to WebRTC, I mean, for example, if two people want to have a conversation via real-time audio video and perhaps using data as well. There are two steps. First one, first we have to like um, do something called signaling. For example, let's say we have Alice and Bob. Alice and Bob have to exchange certain information uh, before uh, flowing direct media between themselves. We call that process signaling. In the signaling process, Alice's and Bob's browsers exchange the information about their capabilities. Using that capabilities, the WebRTC itself should be able to establish a direct connection. Um, we can go to the next slide. So when it comes to multi-party conferencing, uh, there are mainly three topologies. First one is the mesh topology. Um, Second one is the selective forwarding unit topology, or I would say SFU topology. And the third one is called multi-point control unit topology, or MCU. So WebRTC was initially designed. Actually, we can keep the previous slide, please. Um, um, WebRTC was initially designed to be a peer-to-peer protocol. So the mesh topology is about that. Everyone is connected to everyone if you are in a conference call. So this method is not very scalable. If you take a look at the diagram, you would see everyone would be sending media streams to everyone, and they would be receiving media streams from everyone. So it's very hard to scale beyond 5 or 6 participants in a single conference call in this topology. In selective forwarding unit, each participant will be sending their media streams to a central server called SFU, or selective forwarding unit, and that server will take care of forwarding that media to the relevant participant. In this model, the SFU server needs a lot of bandwidth, but it doesn't perform any computation on the media packet quickly. So uh, it needs little bit of bandwidth on the server side, but it serves a lot of computation power when compared to our next method, which is multi-point control unit. So in MCUs, everyone sends uh, their media streams to the central media server, and that media server mixes all the streams up together and forwards to other participants. In this method, you save a lot of bandwidth from the user as well as from the server, but this method is very, you need a lot of computational power in an MCU. So it's not very scalable. And when it comes to cost benefits as well as scalability, you can see SFU, selecting forwarding units, are picking up in the market. For example, Google Meet uses an SFU, Jitsi is an SFU, um, and most of the other open source um, technologies like Janus currently also pivoting towards SFUs. You can put the next one. So WebRTC is kind of a very low-cost communication integration solution. I mean, before WebRTC, it built something like a video conferencing system. It would take tens of thousands of dollars. Even to start it, and it's becoming the new standards of real-time communication, especially in browsers. And there are a lot of cool features coming on the way, like video processing and advanced encryption, so and so. Yes. So I think with that we can start to talk about Jitsi. I think I'll and go back to Achal.